Hello everyone, this is bi-weekly lessons with the KenteCode AI ambassador. So we learn about joins, subquery and CTEs. What is a join? A table join allows us to link rows in one table to rows in other tables. So for example, we have select star. So select star selects all rows from table A, join table B. So we have a table on the left side, which is from the initial table and table B. On table A dot key equals table B dot foreign key column. We have different types of join. We have the join or inner join. It only shows rows that match both sides. We have the left join, that's all rows from the left table and matches the right tables. So if there are no matches, its input null. Right join takes all rows from the right table and matches from the left. Nulls where there is no match, and full outer joins takes all the table where nulls are available for each side which have no match. Cross join makes a possible combination of all rows. So let's take an example where we look at joins from visual join. So from visual join, it is an open source project where we can understand joins by seeing it visually. So we have an example, inner join, and the SQL statement says select users.name, and then we have the users table. The users.name gives us the name, and then likes.like. So the like from the likes table. So from users, join likes on users.id equals likes.user.id. So we are using the inner join. So for inner join, we are going to find matches for the where users and likes intersect. So we have Patrick 1, ID 1, Patrick, and 1, 2. So Patrick climbing will be seen here, Patrick climbing 1. We also have 1, Patrick, we have 1, code. So we have Patrick code here. We have 3, Maria, we have 3 stars. So Maria stars will be here, and then we have 4, Darwin. Darwin apples, as 4 is in the likes table. Now we have left join. Left join, like we say, we will take all tables, all rows in the left table, and then it's going to match it to the rows on the right. So if there is no matching rows, it will bring null. So we have 1 Patrick. So 1 will be climbing. We have 1 Patrick again. We have 1 code. Now we take 2. We take Albert. So 2 is Albert. When we look in the row likes table, there is no 2, so it's going to be null. We take Maria. We go to Maria, which is ID 3. We take 3. We have stars. Maria stars. We go 4. Darwin. And 4. We also have apples. Now we have 5 Elizabeth in the users table. Likes, we have no 5 there, so it's going to be null. Let's go to right join before we come to left anti-join. Now for right join, it's going to return all tables, all rows in the like tables. So for like, we have stars, climbing, code, ruby, and apples. So we are going to look for matching rows in the name. So we have 3 stars, we have 3 Maria, we have 1 climbing, we have 1 climbing Patrick. So that's going to be Patrick climbing, and then we have 1 code, and then we have 1 Patrick. So it's going to be Patrick code. We have 6 ruby, which exists in the likes table. Now there is no 6 here. We are going to have now, and then we have 4 apples, 4 Darwin. So it's going to show us the Darwin in the right join table. Now for outer join, it's going to combine all the users table, all rows in the users table and all rows in the likes table. So now we're going to have Patrick climbing, Patrick code. For 3, we have 3 stars, Maria stars, and then we have there is no for Albert, we have no name here, Albert. Now we go to 4 Darwin, we have apples. 5 Elizabeth, there is no Elizabeth in the likes table. Now we have now here, and then we have 6 Ruby, there is no name for Ruby here. So as you can see, even if it gets challenging to understand, we have to look at the colors of the tables. So we have the blue color for the users table, and then we have the orange for the likes table, and we can see they are all shown in the set as it is done here. So we see the SQL that is written here. So similar to what we were seeing earlier, users.name, likes.like from users, left outer join, likes on user, or right outer join. So for PostgreSQL, we say full outer join because that's what we are doing. We are learning in KenteCode AI Academy. So for our left anti-join, where we input the same select statement, but we say where likes.user ID is not. So it's going to give us for values where the like is not. So we are going to only have the name table that is going to be shown here. So this is a very great resource on how we can understand joins visually. Let's continue. Subquery. A subquery is a select statement that is nested inside another query. So the common uses is filter rows dynamically, and it is used to build derived tables. It checks for existence, and then we can create column values. So for example, say we want to write a query to show which US counties are at or above the 90th percentile or top 10% for a population. Rather than writing two separate queries, we can calculate the 90th percentile and find counties with population at or higher. So let's say an example, we have select county name, state name, population estimate 2019. So from US counties population estimate 2019, this is the table name. And then we have where population established in is greater than. So for the where statement, that is where our select statement is going to be buried inside another select statement. So we are going to calculate the 90th percentile in the where statement, and then we will be able to use that where condition to find the 90th percentile. So this gives us the 90th percentile, and the result gives us the county name, the state name, and the population that is greater than or equal to the 90th percentile. So the result is what we see here. Common table expressions. So that is CTEs. Common tables expressions use with and as to define named temporal results sets before the main query. So in essence, we are creating a temporary table where we can use it, we can query data from. So benefits are it creates a readable code. You have no redundancy, like multiple or repeat select statement. We have it's easy to revise because when there's an error in our code, we are able to make changes quickly and find where the error is coming from. So we have an example here with large counties, and this large counties is the temporary name we are giving for a table that we are going to create. You have county name, state name, population established 2019 as. So with and as are keywords that is going to tell PostgreSQL that we are creating a CTE. So in this with statement, we are creating a select statement to select county name, state name, population established 2019 from US counties population established in 2019, where pop established 2019 estimate is greater than 100,000. So with this, we are creating a temporary table, and the select statement should be matching the temporary tables, the columns that will be selected in the temporary table. So now we are going to select the state name and then count all the rows in the state name and from large counties. So large counties is the table that we have temporarily created here, because this is going to select is going to create a table that we'll be using to select the state name and then the counties. So large counties, we are ordering by state name, that is, we are going to have the highest to the lowest. So state name, we have Texas, Florida, California, Pennsylvania, New York, Carolina, and all these are the count of the state name that have a population that is greater than 100,000. So now we go to case statements. Case statements also known as conditional classification. This is more like an if or else statement in Python. So here we have case, when condition, then we give a result. When condition, then we get else, we have a result, and then we end. So this case, else, and end is a PostgreSQL statement where we is able to identify we are creating a case statement, similarly to an if-else statement in Python. So example, we have select max temperature. Case when max temperature is greater than 90, then hot. When max temperature is greater than, is between 70 and 90, then warm. So we have all of these, and then we have else, no reading. Then we can end as temperature group. So this is going to be a name for the column. a name for the column that will be created for the case statement. From temperature readings, which is a table that we have created already, and we are going to order by station name and observation date. So we have the maximum temperature 31 is lesser, is between 20 and 33, so it's going to be frigid. 34 is going to be cold, given the conditions that we've set here. So all of these are going to be matching to the maximum temperature that has been calculated here. So this is how case statement is, and this brings us to the end of the lessons that we've covered so far with KenteCode AI Academy. So thank you for watching and have a nice day.